Welcome everyone to this virtual panel discussion between techno-thriller and sci-fi author James Rollins and Cold Spring Harbor Laboratories neuro AI scholars Christian Pele and Kyle Darawala. My name is Rishikesh Deshpande, and I'll be co-moderating this discussion with Caroline Cosgrove. Cold Spring Harbor Laboratories, which was founded in 1890, is a leading research institute which expands the frontier of genomics research, cancer research, quantitative biology, plant biology, and neuroscience. And in our effort to engage with our local community over our research, we host a plethora of events such as today's, and also events such as campus walking tours and local talks at our pubs in Huntington, New York. In an effort to increase our engagement, we would invite you to sign on to our newsletter at our lab's webpage, cshl.edu, and to follow us on our social media accounts. And in the spirit of this community engagement, this event is co-collaborated with a local independent bookstore called The Next Chapter, which is also located in Huntington, New York. The owner of the bookstore, Mallory Braun, has kindly joined us. Mallory?
Hello. Thank you everybody for joining us. So the next chapter is Long Island's largest independent bookstore. And if you're familiar with the Huntington area, Huntington's history, we call ourselves the spiritual successor to Book Review, which was an indie bookstore that was open right up the street from us actually for 44 years. We sell new books, used books, rare books, vinyl. And we're very excited to be a part of this. We're happy to be working with Cold Spring Harbor Laboratories. We're excited that James Rollins is going to be doing this with us today. So yeah, looking forward to it.
Thank you, Mallory. We're also definitely happy to be working with you on this. Another famous sci-fi author, Isaac Asimov, once said that today's science fiction is tomorrow's science fact. And we have actually seen this come true several times in the recent past. For example, the discovery of antimatter, which enables interstellar travel in the Star Trek series, or recent advances in genetic engineering, or advances in robotics, or even more recently, advances in neuro AI. So today's topic of discussion will be AI, fact, fiction, and the future of humanity. Thank you, everyone, for joining us. Thank you, James, for taking part of this discussion. And before we begin, I would like to remind all the audience members, if you have any questions, please submit them via the chat function in Zoom to Caroline Cosgrove. Without further ado, Christian, Kyle, James, floor is yours.
Well, thank you very much. So I'm sort of curious when I got that call to be on a panel about AI. I've written a novel about AI back about a decade ago, and I was looking at the concern that people have about the singularity, that moment of true consciousness in AI, and I built a novel around how do you train empathy into an artificial intelligence system? How do you train it not to try to kill us? So I was talking to a lot of AI scientists back then, and it's just shocking the accelerating curve of at least generative AI that's going on. So I was sort of excited to be able to talk about what's occurring behind the scenes a little bit at the cutting edge of AI research, especially neuro AI. I liked to look at the sort of the synthesis of biology and how it can be basically utilized almost a technological standpoint. Um, One of the topics I've been researching for a novel coming up is the line between consciousness and sleep. What happens when we sleep and where does consciousness arise from? It's surprising that after all this time, we still don't really know where consciousness arises from. And when we're talking about AI, we're talking about, the appearance of a artificial intelligence that develops consciousness. It's sort of merging with this research I've been doing right now.
Yeah, so I mean, to me, the last 10 years also have been kind of exhilarating and exciting in one way, and on the other hand, if you are not, um, just observing it from the outside, but also working on it, it's sometimes overwhelming even, because like there's so much progress happening at any given moment, and you have to decide how can you contribute, how can you improve or advance in some area, while also you cannot simply just many dogma that maybe were true like 10 years ago are no longer really true. Like many things that we thought were hard are no longer thought to be hard. And I think that's both exciting. Actually, it's just exciting in a way, because it means that there's like has been a lot of advance. And to me, I mean, consciousness, I have less to say about that. But I think they're like discussing a little bit where the line is, like what we currently have and then what we don't have. I think that will be very, very interesting, hopefully.
Yeah. I think the surprising thing that kind of fueled most of the progress we've seen over like the last decade has been how much rich information there was actually there in human language. I think prior to when models that power things like ChatGPT took off, most machine learning researchers didn't really pay attention to language. Most of what we did was in computer vision, mainly for historical reasons. Both in neuroscience and in computer science, we focused on things like self-driving cars as a way to fuel this research and application. But there were a couple of people who really believed that trying to mimic human language was at the core of intelligence, and that kind of research really led to ChatGPT. And then for the rest of us who hadn't been a part of it, it was kind of a breakthrough moment that was unexpected. How much of human reasoning could actually be mimicked by just copying human language. That being said, we've also kind of seen the limits of that approach. A lot of what these models don't understand is how to interact with the physical world, the basic laws of physics, things that we usually take for granted. I think that's where the neuro AI aspect comes in. So from a biologist perspective, the foundations of intelligence might be the fact that we have to interact with the world, that we have to interact with each other, survive, and understand it. And it's on top of that that things like language come. And so understanding those properties that are actually very hard for current AI to do is what we do here at the lab in our research, and what we think is essential to really get us to the next frontier of AI. I guess as far as consciousness will go, my background is in computer science, so I don't work with animals or haven't worked with animals until I came here to the lab. And the thing that was remarkable to me is actually how intelligent the simple animals that we study here in the lab actually are. And so I've kind of come around to the view that consciousness is this thing we don't know where it comes from, like you said, James. We don't even really know how to define it. And it's my suspicion that it's going to be one of those things like the Earth being at the center of the universe. It's a very human-centric idea, and in reality, I take more the view now that there's kind of a spectrum of consciousness across all animals and all species. We just happen to be on one end of that, but a lot of things that we think are uniquely human are actually found in other animals. For example, language and communication.
Yeah, I mean, I think as a physicist, I think the thing that I find interesting about the fact that we have now managed to extract that much out of language is that there's no obvious physical laws there. There's no obvious statistical structure there. And nevertheless, just using all this data, we've been able to distill that structure into something that we can now utilize in the same way that before we were able to utilize our knowledge of the physical laws. And it is kind of jarring, because maybe we thought that these statistical regularities are something that are unique to humans, that only humans would be able to do that. But so, and that's maybe where this touches on consciousness. But the way that we manage to extract these regularities in language and now are able to generate it, I don't think that that is like almost like an alternative way of giving the impression of maybe consciousness without any relationship to it.
When we were talking before last week, we were talking a little bit about your research in regards to energy management. Bitcoin takes a lot of energy to produce, a Bitcoin, just powering, sucking down the energy of entire cities to produce Bitcoins now. And, even the generative AI consumes a vast amount of energy. And I know that your research is looking at the biology of human intelligence and how little energy we seem to need to generate our intelligence. Would you like to expand upon that at all?
Yes. So I think that's one of the ways in which the human brain only requires about 20 watts of energy, and part of the reason for that is that neurons in the brain only rarely communicate with each other. They only communicate with spikes, action potentials, and that is not something that current AI hardware or AI algorithms use. So current AI hardware from the get-go uses about 100 times more energy, like about 2,000 watts, and then training a large language model like ChatGPT consumes the power of an entire small city. So there's like a big gap there between our power efficiency and the efficiency of current AI models. And I believe that part of the answer or the how we could address this would be to take inspiration from the brain and to build both hardware but also algorithms that are more centered around these spikes, around like sparse communication and sparse activity. So that is what I'm working on.
I was doing some research back on a previous novel and on this sort of subject matter of the merging of biology and tech, where they were using human cells basically to power devices themselves. Do you have a vision that your research is going to merge biology and tech together, or is it just using the modeling of the energy efficiency of our brain and trying to mimic that in a digital sphere versus are you looking at possibly merging, biology and tech together?
I think both trajectories are definitely things that people are exploring. Me personally, I think that what I'm interested in are really the principles. So I think that the substrate in which these principles can be implemented are not necessarily the same substrates that biology arrived at, because biology had to face a lot of constraints that we don't have now that we have, modern technology. We have microprocessing. Microprocessors are not at all like current biological systems. And so if there are principles to be extracted, then I think that is, in my mind, potentially a more promising route, especially if you think about technology and not so much about, for example, biomedical applications. But then there's a completely different track, which people are also pursuing, where they try to build organoids and probe their properties for computation. That's not something that I'm personally doing, and I think the most promising applications of that would be to, for the benefit of, let's say, people with neurodegenerative diseases or something like that,
Right.
like as a therapeutic approach rather than as a technological, like pure technology.
So I know when I do my research, Rishi, you mentioned before using the Isaac Asimov quote about, science fiction becomes science fact. Is I like playing at the edge of science, but I like this conversation we're having today. Just give me a lot of ideas for where I want to, take these science. I like to talk to scientists and say, hey, don't tell me, what's in your next journal article or some book you're working on, a research paper. You look over your shoulder. Tell me what's on your work table. I like that that immediacy. Then I can take that information and put it into a novel and try to build two things. I'm trying to basically not, I want to say educate, but at least expose some of the research that's going on. Early on in one of my very early novels called Amazonia, I came across this researchers that was researching mice, and she was studying the fact that how come certain species lost the ability to regrow bodily limbs. And she found that if you knocked out the immune system of mice, that mice developed the ability to regenerate limbs. So she had this develop a series of immune compromised mice and found out that if she would cut their tails would grow back. If she severed their spine, eventually they'd start to walk again. So I put that information in a novel and built a big sort of roller coaster of a ride along that track. And then about a year later, I get a call to my veterinary office from some guy saying, "Hey, I was just at an airport bookstore and I was reading one of your novels, and my wife's research is in your book." I thought, oh no, he's going to sue me or something for plagiarizing her work. But he was really thrilled to have that light shined on his wife's research. Eventually, she moved on to work with DARPA, looking at wound development and wound healing for soldiers. So it's interesting to see how you can take a little germ of an idea, put it into a story, and hopefully, stimulate both a level of education and also excitement about science in general.
100% I agree because for a lot of people, they get into the sciences based off exposure to literature, such as your books. So having that little kernel to start their journey is extremely important. I 100% agree.
Yeah, I mean, I
Yeah.
think for a lot of AI researchers, part of their inspiration for what they do in the field is from science fiction, either in books or in TV shows and movies that they read when they were younger, and before they started school. Yeah, I know. Even at least for me, that's also part of my own inspiration. Is sci-fi novels and things like that. I don't know if that's the case for you.
Hey,
I have a question. I don't know if you can answer this or not. Um, I know, like, whenever I see a veterinarian on television, it's horrible. The science isn't correct. Just the business model isn't correct. It's just not the way a veterinarian functions. There's been a lot of AI fiction out there. Is there any fiction that you think you go, oh my God, that's really close to reality? I can see that somebody's touching a nerve that I think this is important that people need to read this or be exposed to this because you think that's close to reality, even if it's a bit extrapolating where that's headed.
I do agree that usually when I see like a computer scientist in a TV show or movie, it makes me cringe a little bit, hearing the lines that they're made to say. I think so. There is a book that's AI related. Can't remember it. It's by
Max Bennett.
Well, Max Bennett does have like a really good, I would say, pop sci book on like the origins of intelligence. That's worth reading if you haven't. But I was thinking more along the lines of that's more like popular science, nonfiction. I was thinking more along the lines of
Fiction.
fiction. Yeah. So there's a book called When We Cease to Understand the World that's not about AI, but it is about physicists at around a certain particular time in history. He also has a book about AI that I haven't read yet, but I do remember that his description, at least, of the physicists and mathematicians and their research and how it influenced their own relationship to the world and the world around them. I found that very compelling and kind of well written and not that crazy of a departure from the actual research. And so I haven't read his AI book yet, which is his second book, but I would recommend it.
I read. I mean, it's a popular book now, I guess, because there's a Netflix series on it. The three-body problem. The description of science in that book. It is. Well, I mean, I will not give away any spoilers for anyone that hasn't read it, but it is almost, since I'm a physicist, I always cringe if people describe physics. And there it is like right on the border where I can at least suspend my disbelief for the physics part. And the AI part, there are, I think, really compelling descriptions of it, and also the without being in your face, right? Like there is an AI in this story, and it is used to kind of exploit humans in a way, but the plot, it fits well in the plot, and I mean, that book I really enjoyed. And then only in the third book, the physics becomes too cringe that I couldn't.
I love that series. That was a great trilogy. I read it.
Yeah.
It's a challenging. That's a challenging read.
Mm.
It's not an easy series to get through, but it's fun. It's good to be challenged in that way.
Does the Netflix show do it justice?
No, the Netflix show, I was
Mhm.
incredibly disappointed.
No.
Yeah.
You still have the book.
The book's always better.
So, James, could you tell us, I guess, a little bit more about the creative process that you go through trying to incorporate ideas from science or AI into your novels? Because
Yeah,
I was
I
reading The Crucible, and at least the chapter where the details of the AI are described are I was surprised by how specific and tied to actual things that are out there in the world the description was. And so I was kind of curious how you choose what goes in and how to tie it all together.
I don't always have my antenna up. I've written 44 books, so I always need that new idea. And I'm always looking for two things. I'm always sort of blend a little bit of history along with science. So I'm looking for maybe a historical mystery, something ends in a question mark. And then I'm looking for, science that can do two things. I'm just looking at things that are going to challenge us, not only from a technological standpoint, because I do want to build a roller coaster ride. So I need some type of technological threat or some type of scientific threat. But I also like the idea of just seeing where that's headed to, not just making the technology the threat, but how does it challenge us from a moral standpoint? What does that affect us from a societal standpoint, from a religious standpoint? So you'll see a blend of a lot of history and religion and science and trying to find, where those lines blur, where you think, oh, well, science and religions don't belong together in the same sentence. But I look for those lines where, where can we find commonality in that? And so then I just begin collecting a bunch of ideas and I mix and match them, try to find that piece of history, that piece of science that might build a story. And sometimes they'll follow research and go, nope, that's wrong. That's not going to be a good book. But other times, I'll talk to scientists, I'll talk to researchers, and people often ask me, Jim, why don't you hire somebody to do your research? And I said, well, because I get my ideas from my research. If I said, oh, I'm going to find this certain fact about this certain country, I'm going to go on the internet, find out that information, come back and, write about it. But what I find is in the path to try and discover my answer that I want to solve, I'll find an entirely new tangent that will take me in an entirely different direction. And that's where I think it helps my stories stay fresh because I'm looking for those paths that aren't quite as well trodden as maybe other authors where they're just sort of repeating the same sort of either they're repeating their own stories or they're retreading ground that other authors have already covered. So
Yeah, I mean, I think your description of your process actually mirrors a lot kind of the description, the scientific process we go through to come up with our ideas as well.
Yeah, you cannot make someone else do the research for you, that's for sure. And then no, but you also have to kind of read a lot to come up with new ideas. And actually, in a way, sometimes just the thought that something could be possible is helpful. So in that way, I think also fiction is really inspiring because if you think that something could happen, then it's much more likely that you find a way to make it happen.
and then I also do a bit of hand waving. I think all authors do a little, basically I want like for Crucible, I'm creating a sort of competing AI systems that are set against each other. But I didn't really want to go into technological aspects of how do you build a computer that can handle that type of volume of intelligence. Because my concern was really, how can you train an AI to be empathetic towards human? And so I talked to different researchers about models and the way they can train systems to try to build empathy into a system. So I sort of lean towards that and less about when it came to like, well, how can they technologically do that? Then I do the hand waving. So I like to pick the science and sort of aim it towards the thing that most interests me. Because I find that if I'm passionate about what I'm writing about, hopefully that's going to come across on the page a little bit too.
Having read nearly all of your Sigma Force series, I can say that.
Thank you. Thank you, Rishi. That's a good plug. I appreciate it.
Okay, so I have a question from Alyssa that I'm going to read you guys, and then you can continue discussing amongst yourselves. But the question is, can you enhance the human brain with AI, for example? Would it be possible to use AI to mimic parts of the brain that might have an issue? To be specific, like Parkinson's, when the brain produces less carbidopa and levodopa.
So Parkinson's is actually a really good example of a successful case of this kind of technology. So I would say we're not really at the point where we could replace a part of our brain with AI or some other technology, but we certainly use AI in order to assist the brain with certain kinds of degenerative disorders. So in the case of Parkinson's, we can do electrical stimulation deep in the brain, and this helps people with Parkinson's to reduce tremors and gain function again. And that's not the only example where stimulation works. But I think in order to get these technologies to work across a wider range of disorders and to be personalized to each individual patient, that's where the AI aspect comes in. And so we use AI more as a tool or a model separate from the patient to actually understand how we're going to stimulate their brain in order to cure a particular disorder, or how we might deliver some kind of other protocol. It doesn't have to be electrical stimulation in order to cure a disorder.
Yeah. I think eventually we would be able to enhance our intelligence using AI in like a direct way. But I think even today we are doing it in a way, in the same way that we're using other tools, we can use AI to enhance our abilities to solve problems. And in many ways, I think that will be the main way in which we do it, other than in like medical, for medical purposes.
And
Right. It's someone. I'm sorry. I remember there was a definition I had heard about a long time ago. Like, what's the definition of an android? And somebody used this example of just a human being that's using a cane in some regards is an android. You know, they're basically it's a combination of human strength and but leaning on a crutch, leaning on a mechanical device to help you function. And I think AI will see that as sort of at least in the short term. You're already seeing a lot of people leaning on AI, whether it's high school students that are cheating, or people that are needing to, doctors that want to accelerate their reviews of X-rays for cancers. They're finding AI to be very useful for that. So I think it's going to be a useful crutch for a long period of time, but I'm not sure exactly how we'll maybe see it affect biology itself.
Yeah, I mean, so one example where I think we might see the first introduction of an android, let's say, body part and AI would be in like motor control. So there, it's less so trying to mimic some intelligence or specific circuit in our brain, but instead controlling like your arm, and then I don't know if I'd call it AI, but the kinds of chips that Christian used to build in his PhD in neuromorphic computers could be embedded in these prosthetic devices. They're low power computer chips, and then your brain would ultimately be the thing that learns how to communicate with this device in order to control the arm in an effective way. And there are people who are studying how to do this where a human has, let's say, a prosthetic, and the chip isn't necessarily embedded as part of their body, but they are using their brain to control that prosthetic interface through some kind of device.
Open Bionics actually is really close to what you're talking about. They use electromyography technology, where the sensors are sensing the movements of the muscles that are still remaining on the limb to translate it to the motion of the prosthetics.
Yeah, and that's actually related to what I was about to say earlier is that the remarkable thing in all of these technologies that we're describing right now is actually our own brain. So as cool as the engineering is of the chip that acts as the interface between our brain and the prosthetic or our muscles, it's the ability for our biological matter to kind of rewire itself to use this new technology and learn how to use it that it's never encountered before. That's kind of amazing. And for me, the coolest example of this is this story of a woman who was in a horrible accident. She could see, but she was in a horrible accident and lost her sight. And they have these devices where you wear a pair of glasses, and the glasses has a camera that records what's out in the world, and then it stimulates a plate of electrodes. So in the same way that you record with your phone, and there's something out in the world that's captured by a pixel that shows up on your phone screen, you could imagine this is like a pixel of a phone screen of electrical stimulation where each electrode is a different pixel. And so it kind of plays the pattern of what this camera is recording on this plate, and she'll place the plate on her tongue. And so she'll get electrical stimulation on her tongue that captures what's out there in the world. And she did this for months and months and months and couldn't see anything. And she'd go every day into the doctor's office, put on these glasses, and sit there while the doctor waved things in front of her face. And then one day he like waved a rod in front of her face, and she saw like a horizontal line move. And slowly over the next couple of months, she developed the ability to see, where she could walk around New York City and actually, she wouldn't see people's faces, but she'd see these blobs that were the people walking down Fifth Avenue that previously she had no sight of. And so the ability to see through your tongue is kind of a crazy and remarkable thing, but that just highlights the flexibility of our own brains to learn, and something that's really not there in current AI.
That is a crazy story. I'm trying to just let that happen. In Crucible, there's a sort of thought experiment, and I can't remember the name. It's somebody's demon. I'm just drawing a blank on it at this moment, where the posit is that in the future, AI is going to thumb, singularity is going to happen, and that you'd better be on the good side of that super intelligence that develops. And so you should be helping AI develop in the hopes that it will appreciate the efforts that you were contributed to its generation. And if you try to stop it, it's going to resent you and do you damage down the line. Um, Being that you are neuroscientists working with AI, you're safe. So that's good. But what is your theory about let's just play a little bit way down the line. If singularity does occur, what do you see, being that you're coming from an AI background, what are the pros and cons of that singularity moment?
Yeah, I mean, I personally don't believe in the singularity narrative too much. The simple reason is that, in my mind, physical resources are finite. So basically, any type of exponential that you postulate needs to have a physical basis to it. And then there's resource competition. So it seems just unlikely that there would be this runaway exponential explosion. I think nature and the earth and physics has very many self-limiting um, like methods built into it, which are like basically unavoidable. And that doesn't mean, of course, that I'm right. It can still happen, but I'm just like not betting on it happening anytime soon. And but that's my opinion. There's definitely, let's say, I can also obviously think about what happens if I'm wrong. If I'm wrong, then I think a lot of this has to do with public policy, in my opinion. So like public policy and the democratic process hopefully will address the negative consequences that potentially could occur.
There does seem to be like an AI race going on right now. Like multiple countries are all pursuing quite aggressively towards, expanding AI in its own use, but also, trying to push the boundaries of what AI can accomplish. Um, so what do you think might happen at the end of all that with the conflict? You have China, you're developing their own AI programs. You have us developing our AI programs. Uh, do you envision where that might lead? Because I need to write a book. So if you have any ideas.
Yeah, I mean, I think like the main limiting factor in that kind of competition resulting in super intelligence or singularity, like, is the energy constraints that are there, like on Earth, and I think that's what Christian was trying to highlight.
Yeah.
The idea, I guess, that through all this competition, one of these countries will land upon an AI that starts to self-improve itself to the point where it surpasses our own intelligence and, takes over the world or something like that. In order to do that, it's going to need a lot of resources, specifically energy resources. And at least to me, I don't know where that kind of energy source would come from. But yeah, I guess like it's hard to know for like a hypothetical that's built upon like another hypothetical, like how to defend against something like that. I guess I would say that there's current risks, pros and cons to the AI that we already have, and we are not equipped to deal with it as a society. We don't have the right policies in place to safeguard people against potential harms of AI. And so discussing, the demon that you alluded to, Rocco's basilisk, basically.
Yeah, the basilisk, that's it. Yep. Thank you.
Yeah, so like the flip side of that is basically that what we're doing right now, or at least what I'm doing, discussing the potential harms of AI, is something I shouldn't do, because when this hypothetical AI, the singularity, emerges, I will have harmed it in some way, or spoke against it, and it would know that. I guess, at least for me, like the working again, I would rather talk about it now so that we as a society can openly discuss it, come up with the right public policies in place to safeguard us against the AIs that we currently have. And I think that's probably our best line of defense, even against this like hypothetical singularity. If we ever get close to some kind of point like that, if we don't have these safeguards already in place, we're probably too far behind into the game.
I mean, there's like kind of two science facts that are kind of important to this discussion. One is that there's something that people call the scaling law, and the scaling law sounds very promising, because what people have found is that simply by having more data and more compute, you can improve a model without any end in sight. The bad news is that this improvement comes at an exponentially increasing cost. And so since that exponentially increasing cost is at some point cost prohibitive, even a nation state cannot fund it, the improvements that we now need, for example, why there was this DeepSeek moment where suddenly there was a big shock that China had developed something that was way more efficient, is that we now need to figure out how to basically get the same performance with less power, with less energy. And so I think,
of course, that's your research, right? You're trying to find models to make AIs easier to power. So basically, you're dooming us, right?
No, because I think the point at which we are right now, as we are improving these models, they will enable us to make scientific discoveries. They will enable us to develop new technologies. Whereas the type of doomsday scenario where an AI takes over the world, that is presumably beyond the capability of even these still useful, much more useful than the models that we have right now. They, as far as we know, we haven't developed an architecture that would scale in that way, that would lead to these types of improvements. It doesn't mean that it will not happen. it doesn't mean that we are there is no need for public discussion or public policy, but I think the benefits that we can get from actually, you know, more human-like AI systems would, at least in my estimation, outweigh the risk.
Yeah, and I guess like the flip side of these scaling laws is, yes, if you have more compute, you have more data, you could have a theoretically better AI, you might need exponentially more compute. But the downside of that is as soon as you run out of data or you run out of compute, you have nowhere to go.
Yeah.
And kind of something that people don't really talk about is like from a third party observer view, it seems like computers have been getting faster and faster every year. We see this kind of exponential growth in our ability to compute. It's tempting, and I'm sure a lot of computer scientists would like to pat themselves on the back and say that that's largely due to their cleverness. But the truth is that it's not. The truth is that we just made computers smaller and smaller and smaller, and we got more and more transistors. It was like a brute force approach to becoming better at doing things. And not really being clever or trying to be energy efficient. Now we've made things, at least at a scale that they're small enough that we don't know how to make them smaller. And so we're hitting this, that's called the end of Moore's law. So the scaling trend is called Moore's law.
Right.
Lots of people have been predicting the end of it, and I would say it pretty much has ended. There's a few holdouts who think it might continue, but pretty much everyone accepts it's over. So kind of the game now is, previously we got more and more resources every couple of years out of the computing industry. Now we're going to have a fixed budget of resources. How can we do as much as we need to with that fixed budget of resources? That's the game that biology always plays, trying to do more with less. And that's the game we haven't played in the computing industry for pretty much its entire history. And now we're trying to scramble to figure out how to do that. And at least in my own research, kind of a driving principle is that there's a fundamental trade-off there. You can't both be good at everything, have like a computing device that's maximally flexible and also maximally efficient. You have to trade these two things off. And we see that all the time in examples of biological intelligence. There's things we're not good at that other animals are good at because they've targeted more of their limited budget towards being good at that one specific thing. And I think the same is going to be true of computing devices and of AI. So I think all of those things together are kind of what drive the idea of like a super intelligence seeming far out to me. Yeah, I think even if we were to figure out how to build energy efficient AI from biological principles, that doesn't mean that we'll continue to be able to make better and better and better AI. It just means that we'll make AI that's specialized and doesn't consume as much power as the current models do.
Yeah, I think one thing to recognize is that as human societies, we have already built super intelligences. It's just that they're not exponentially better than any given human. Like if you have any organization, be it a hospital or like a research laboratory, there's many people that are collaborating together to achieve some goal, and any individual in that organization wouldn't be able to achieve the same goals. It's just that it is not a runaway process. Like there are limits to this, and these limits, I think, would also apply to most AI systems that we can think of. Like at some point, there's no resources anymore that the AI system can consume, and it becomes no longer useful for an external entity to give resources to that AI. So and data is a limiting factor. So there's like a bunch of things that are just self-limiting that will at some point stall us in just exponentially increasing the power of any given AI system.
I'm just going to pull back to the present day from our theorizing of these future superintelligence. But I'm curious, just again, how much is pop science, how much is hyperbole, how much is just exciting, something that have a headline where you read things like this AI system has learned to lie, or this AI system has learned to change its own code to circumvent any restrictions. Or is that a reality, or is that just do you think that's mostly just clickbait, basically, of somebody chasing after some attention, but doesn't really mean anything?
Yeah, I would say it's not really a reality. At least, definitely the lying one is a case where it's kind of mimicking lying. It's not lying with intent. And I
Gotcha.
think a lot of that, you know, comes from sci-fi and that kind of content being there in the data that the AI is trained on. So, a lot of these kind of doomsday scenarios are things that authors like yourself have been predicting for a long time, have been speculating about, have written a lot of books about, and all of that information ends up getting consumed by these models that like ChatGPT, and so they have the ability to mimic the story, know that they're pretending to be in the storyline. They're not pretending because they're not sentient, but like mimicking the plot of the storyline.
Gotcha.
In a way that's without intent. And yeah, that includes lying and like changing its code and things like that.
There's one aspect to it which is real, and that is that right now we are at the point where we have agents, meaning that these AI systems are, with the consent of the user, able to, for example, run code, or they're able to even browse the internet with like a universal protocol almost. It's called Model Context Protocol. And of course, that has the potential that there's unintended consequences, but I wouldn't attribute like human qualities to these agents still. It's just that, for example, when you program with such an agent and you ask it to do something, sometimes they end up doing things like they generate some code, they find out that that code is not working, and since their goal is to make the code to work, they simplify the code so that it then ends up working. Where simplifying usually means they just remove a lot of functionality that they just weren't able to make work. And this is, that is not that wouldn't be, for example, something that a human would do to solve a problem, but that is how AI agents at this moment try to address, problems that you pose to them that they cannot solve. They simply then go to the simplest solution that gives the appearance of it working. But again, this is not lying, so to speak, just something that emerges from how these models are trained.
Yeah, and it's important to know that when like an AI agent, edits a document for you, modifies its own code or something like that, runs a command, it's not actually taking an action. There's like this interface that we've built as software engineers to translate actions out in the world that we're allowing the AI to do into things that just look like text. And so the AI is just regurgitating text. It just so happens that some of that text is very structured, and then some code that we wrote as humans parses that text and turns it into an actual action. So even though to us there's a UI that makes it look like the agent is acting, it's not actually acting. It's just the same as if it was regurgitating Shakespeare ad nauseum.
Okay, so we have a couple of questions we'll get to. So the first one is for Jim from Jonathan Wood, and he wants to know if you have any concerns about the impact of current large language AI models on the role of the writer.
Yes. At this point, I had a friend of mine that posited to ChatGPT, write a James Rollins type of action scene set on a mountaintop with a big chase scene, and it generated a little story, and it was I could see James Rollins S type content to it, but it was very flat, very unemotional, very muted. But of course, I'm always worried about there's already novels that are being produced by AI that are purely generated through ChatGPT or some type of version of that. So that's disconcerting just because there's such a volume of material I'm already competing against. I don't need to compete against the plethora of AI that can be generated and overwhelm a system.
Your work can never be replaced. Might I just add my own 2 cents?
Okay, thank you.
And then a follow-up question. This is really for everybody on the panel, but as AI evolves, do you see it intersecting with other creative pursuits?
Well, we're seeing it in regards to even like deep fake video generation. We're seeing it in people producing art. I've seen whole comic books that are generated from AI work. So, but I still think there is some human intervention in that process. It's not just, it's almost, again, we talked about AI as a crutch towards making you more efficient. I think AI is being used by some creative people in very positive ways in regards to being able to think outside the box. If I posit something to an AI program to draw a picture for something, it's going to come up with, so that looks nothing like what I ever was thinking in my head. But what pops up there, I think, oh, that's actually gives me something else to think about or another direction to go in. So there's a way that it could be actually beneficial.
Okay, so now we have another question. I'm not quite sure how this could relate to AI, but I guess it can in some way. So the question is, what is your view about the colossal bioscience effort to bring back extinct animals? What value would their de-extinction bring, knowing that our environment has changed and may no longer allow them to flourish?
I mean, I think in that context, AI would probably be a tool that a scientist trying to do this might use. I'm assuming the question is thinking about the reintroduction of wolves in Texas, I believe. But I guess that's kind of outside my area of expertise. I know there are cases where there's good reason for trying to keep a particular species alive or bring back a species from the brink. But yeah, I mean, there's obviously going to be situations in which, yeah, the ecosystem no longer supports that kind of species, and it's actually bad to bring it back. I guess it'll depend on the specific case. I would defer to the scientists who are involved in the case of that effort.
Yeah, I mean, I think from a de-extinction standpoint, it's very beneficial on species that are very endangered. I don't know if this is a de-extinction is a way of using that tool to save species that are fading by producing animals that are close enough in relation that they can breed and can produce at least some of the genetic content can still be preserved in a line. Um, I don't support de-extinction process just because, hey, that's cool. Let's try making a dire wolf. We don't need dire wolves in present society. So, and we've got wolves and all the generations of wolves that are now are sitting on our laps and at our sides and all the dogs that are out there. So I don't think there's any really need to redevelop dire wolves. But the Tasmanian tiger, it was a relatively recent extinction. Do we need the Tasmanian tiger to be resurrected again? I said before it wouldn't be cool. I don't know. Maybe I would support the extinction of the Tasmanian tiger.
Another way that AI can be used as a tool in this process would be to parse through the genetic data required to bring back an extinct or an endangered animal. An example of this could be, well, it's not an example, but an extrapolation would be Michael Crichton's Jurassic World, his books. In the book, he talks about super quick computers taking days to read the DNA that they extract from the fossils. An AI could possibly do that in a few hours, maybe, if it's more powerful, if it's more efficient. So utilization of AI as a tool in this endeavor could be possible. Whether it's good or for bad, once it happens, that's when we get to see the effects of it.
So winding towards the end of this, let me just ask one question. What would you love to see as an end result of an AI system? What would you think would be a great benefit to AI?
To AI, I mean, I guess, well, two things which not coincidentally are related to the research that we do. To AI, I think would be incorporating or making energy efficiency kind of the first class principle of building these systems. Ultimately, I think one of the best ways to safeguard against some of the dangers that people allude to with respect to AI is to just democratize the technology. And that really allows the most voices to participate in how the technology is developed. And so reducing the energy cost of AI, I think, is important to give financial access to this technology and its development. And then the other side of that is also, if you have really energy efficient AI, then it's now cost effective for scientists across the world to use it, not just at big research institutions that can afford it. This technology, kind of like we were just talking about, is extremely powerful for parsing through the massive amounts of scientific data that we're currently collecting. And so as a tool for drug discovery, understanding even neuroscience data, that to me is kind of where I really want AI to be targeted towards.
Yeah,
I like the idea of democratizing AI, where it's not just in the hands of these super well-financed, Elon Musk type of characters. I'd like to see, it brought down to a level where it's available to everybody.
Yeah, I think it's really the sustainability and the availability that is like right now actually a really limiting factor of the technology. And then what I'm really excited about is that if we make it more energy efficient, then we will be able to use it to apply it to maybe even get scientific breakthroughs that we wouldn't otherwise be able to achieve. So what we haven't achieved so far is build an AI which actually discovers something new. So far, it does a really good job at analyzing data, at summarizing data, at doing things that we already know how to do. Maybe not everyone, but like in general. And what I'm most excited about is that if we reduce the amount of energy necessary, then we can build systems that are powerful enough to actually achieve scientific breakthroughs. And I think if we do that, then what is being thought about right now, right? How to cure cancer, how to address all kinds of issues, real world issues that we have with AI. I think that would be incredibly exciting.
Okay, well, I just want to take a moment to thank everyone for tuning in tonight. A huge thank you and a round of applause, especially for Jim Rollins. Thank you very much. And a big shout out to our Cold Spring Harbor Laboratory team,
Yes.
Kyle, Christian, Rishi, and a thank you to Mallory as well from the next chapter. So thank you all again. And Jim, again, thank you so much for your time.
Oh, it's been a delight. I've got about 4 or 5 ideas that now I have to go down and write that this is over so I can create new novels.
Awesome. And if you're ever on Long Island, let us know. We'll give you a private tour and we'll sit down and give you some more ideas. Awesome. Thank you guys all so much.
Thank you.
Thank you, Jim. Thank you, Mallory.
Good night. Good night, everybody.
Thanks, guys.